Hello, 大家好. So today I'm going to give a talk about some of my experiences integrating Ruby and Elixir apps in production at my company, which is called Tote. So by way of introduction, I'm primarily a Rubyist. Most of my experience with Elixir is from reading it in our code base, but not actually working on it. And the goal here is to give some like specific examples of how we've integrated our application. Yeah. So about me, I'm a software engineer at Tote. I've been working at Tote for about 3 years, and before that, I was a software engineer for a year at another company, also writing Ruby. So about 4 years writing Ruby at this point, and I'm self-taught, so I didn't have any experience. I didn't go to a boot camp or learn coding at university or anything. And Ruby's been a really big part of what has, it's a huge role in my sort of introduction to software in general. So want to talk a little bit about my company, Tote. We're a startup based in San Francisco, and it's a fashion rental subscription. So basically, what that means is that our customers go to our website and sign up for to pay a monthly fee to access to clothes and accessories that they can pick out for themselves, and then we'll send them to their house. So the cycle is basically the customer go on the site, pick out some clothes, they can browse our inventory, see what's available, what we have in stock in their size. Then we'll prepare the tote, so we have to go find that on our racks. We have a huge distribution center in Stockton, California. We're about to open another distribution center, so we figure out where are the clothes in our warehouse, and then deliver them, pack it into the tote, ship it by shipping labels, other things that go into logistics of getting the shipment to the customer, which we call the shipment a tote. So then once it arrives at the customer, they can try on the clothes, see if they like them, wear them. Ideally, someone will compliment them. So a coworker will say, "Oh, I really like that on you," and then they can buy them as well. But if they just want to get something else, then they send it back. And as soon as we receive it back, then they can pick out new clothes. So it's important to understand the domain, because I'm going to get into sort of how we started to approach splitting this out from a Ruby monolith. So Tote stack is going to be, I think, familiar to a lot of people who have worked on a large monolithic Ruby on Rails application before. The application was started in 2013, so and it just expanded organically to where it is today. And it's expanded as our team has expanded as well. So we started out with 2 engineers, scaled up now to about 30 engineers, and at various times, most of them are working on our Rails application. For databases, we use MySQL and Redis. We host on AWS. And for the last 18 months or so, we've been getting into using GraphQL to design APIs that can be used by our clients. We support 2 different clients, an iOS application and a JavaScript-based web application. And for the JavaScript application, it's a Redux and React Redux JavaScript app, which we don't serve through Webpacker because that didn't exist when we started, so it just uses a separate build pipeline. So, when I talk about integrating Ruby and Elixir apps in production, what does that mean? So we made a decision about 2 years ago that we wanted to start breaking out some parts of our application into services. And there's a few different reasons that we had for doing that. First is that as our team grew, like I said, from 2 to 30 engineers, it became harder and harder to work on one giant application at the same time. The rate of change is hard to comprehend. You start to lose track of all the different things that are going on. You start running in conflicts working with other developers. So one of the main reasons that we wanted to split it out is so that there were fewer programmers working on smaller repos. We also work at different scales. So we have two main users of our web application. One is the customer, who wants to go on our site, browse the different clothes, manage her subscription, deal with payments and billing and her address and all the different kinds of information that are customer facing. But we also have a second client, a second set of users, that's our internal workers. And for our application, actually 95% of our web requests were not coming from our customers, they're coming from our workers, because we use our software to manage every aspect within our fulfillment center. So finding the clothes, shipping them, all the different aspects of getting from what the customer requests to getting it out the door and sending it to her, and then getting it back. Most of that traffic was actually being generated by our own users, not by our customers. So that was one of the reasons, is that to let us work at different scales. And this really ties into the last point I put on here, which is to deploy and manage our domains separately, because we ran repeatedly into situations where a change that was intended for the customer-facing aspect of our website would take down our warehouse. And then we have 200 workers in our warehouse who can't do their jobs because someone was trying to tweak the user-facing part of the application and accidentally broke something for them. So it really allows us to manage those two different use cases separately and not be worried about, okay, we can't deploy today because we need to wait until the warehouse workers have gone home for the day so that we're not wasting their time. And it also allowed us to use different technologies together. So one of the things that we wanted to do is start working in Elixir, and you can't do that within a single application. So why did we want to use Elixir? Or why should we use Elixir for Tote? Well, first, the team wanted to use it. A lot of our programmers had an interest in it, like the syntax, like the capabilities and possibilities, just generally interested in learning about it. And definitely the best way to learn a programming language is to use it in production, and so that was one reason that we wanted to use Elixir. Another is that it's created a tremendous hiring advantage for us. So being based in San Francisco, it's an extremely competitive market. It's really hard for us to hire software engineers. And being able to say, okay, if you come and work at Tote, you can use Elixir, has been a really, really great tool for us and really helped us convince people to come and join our company. Third reason is that it lends itself to the domain. I originally had a question mark after this point because we had a lot of specific ideas about how Elixir might be good for what we were doing, but I'm not sure that we really necessarily had a concrete idea about how we're going to use them. So one idea is that we're going to use in-memory management to keep track of all of our different clothing items that we have. Like, where is this particular shirt located in the warehouse? Or is it at the customer? Or is it in the mail? Like, where is this item? And we actually haven't been able to take advantage of that yet. But something that we have been able to take advantage of is using Elixir to write software for embedded devices. So we're one of the primary sponsors of a project called Nerves. And Nerves is a way of using Elixir to write programs for embedded devices. There's a bunch of different devices, but at Tote we primarily use Raspberry Pi. And that project is maintained by this guy, Justin Shunk, who's one of my coworkers, and has been really great because it allows us to build out custom hardware for different operations that we want to do inside of our fulfillment center. So actually we have, for example, we have a station where the worker at the warehouse will pack all the clothes into a box, and then we need to weigh the box to find out how much postage should we buy to send it to the customer. And so what we've set up is we have a Raspberry Pi running our local software, maintaining connection to that scale, to barcode scanners, to printers so that we can print the shipping labels, and then communicating back taking advantage of Elixir and sending messages to the server all at this one station. So actually, that's in one sense that that Elixir has really lent itself toward domain. And so what we've decided going forward is that we're actually going to be Elixir first for all new services that we want to build. So when we started thinking about splitting up our Rails monolith 2 years ago, sort of ended up that we wanted to split it down this dotted line. So on the left-hand side of our monolith, you have things that are decidedly in the customer domain. Things like payments, subscriptions, the customer's size and style preferences, what kind of clothes does she like, what size clothes does she wear, and then her ratings. What does the customer think when she wore a particular shirt or dress? You know, did she like it, does she want to keep it or not? And then we have totes, which are our shipments, and that really split the line because there's an aspect of that belongs to the customer domain, which is, you know, what did the customer ask for? And then there's aspects of that that belong to our fulfillment domain. And so what's the status of packing this order, buying the shipping, all the fulfillment related aspects of that. And there's things that decidedly have nothing to do with the customer, like our inventory systems. How do we know how many items we have in stock, and things like our cleaning process, which is only facing internal fulfillment users. So what we decided on is, our ideal is that we're just going to split down the middle, and then also to really expand on some of those aspects that so all these different things that would combine together to be like, okay, the order, the tote, we're actually going to split up into the different aspects of it. So really going and getting the order off of the shelf is different than packing the order, which is different than buying the shipping, which is different than processing the order when it comes back to us. Which leads me to the meat of the talk, which is communicating between Rails and Phoenix. Now that we've decided that we want to have a Rails application and a Phoenix application, how are they going to interact with each other? And the reality is that there's no secret technique, or there hasn't been for us, that is any different than any other service-oriented architecture or any other situation where you're going to have multiple web applications talking to each other. Now, I put an asterisk here because I think that there probably are some cool things that you could do to communicate between Rails and Phoenix specifically, maybe using channels and action cable, some other sort of real-time communication that takes advantage of the features of the language. But the reality is, for us, when we're actually building our application, we haven't needed it, nobody else is doing it, and we just haven't had time to explore that because we're trying to run an actual company based on these technologies. So for us, there's no secret technique for communicating between Rails and Phoenix. So I'm going to talk about 4 different approaches that we've used today. I sort of made this chart where I divided them into hacky approaches and stable ones, and synchronous communication and asynchronous communication. So our hacky synchronous communication strategy is writing straight to the database. So when we're spinning up a new Phoenix application and it needs to know about information that lives in our Rails application, we can just connect straight to the same MySQL database and read that out. Or alternatively, insert new records into that table. Asynchronous, using background jobs that we already have. So I'll get more into exactly how that works. And those are our hacky approaches. And then our stable approaches, which are maybe take longer to build out, but are more predictable in their behavior, things like using HTTP APIs and using a message queue, something like Kafka or SNS, SQS, something like that. And what I want to point out before I go through these is that we've been doing this for 2 years, and we still have all of these different ways of communicating in production. We didn't get rid of any of these over time. They'll still continue to work for us. Yeah, so first I want to talk about communicating synchronously by reading and writing straight to the database. So when you're thinking about building this out, it's something that we used in one of our earliest prototypes, specifically about finding out where particular items or clothing are located inside our distribution center. So the major pros when we were building this out is that, one, there was absolutely no changes that needed to be made to the customer app, because really our Rails monolith is oblivious to the fact that this is going on. We don't know that some other application is coming in and messing with your database. And second, it was quick to build because we didn't have to coordinate across teams. You just go ahead and do it. So it's sort of give you an idea of what that might look like, but basically we have our database in the middle, which for us is a MySQL database on AWS. We've got our customer app, and then over here on the right, we just plug in our new fulfillment app, which is written in Elixir Phoenix, and just start talking to our relational database. So if you're a Ruby developer, Rails developer, you're probably familiar with like an active record model where you might have validations, you might have some callbacks that also happen where there's an effect of modifying your records. It looks something like this. And one of the problems that we face when you write straight to the database is that you lose all of this. If you're writing straight to the database, then you don't get to take advantage of all this business logic that exists in active record. So yeah, you can see on the left is we've defined the schema separately in our schema.rb file. We've got our active record model. And then you can see basically the same model that we recreated in Phoenix. So we're using Acto to define, Acto is your package as a sort of equivalent to active record in Elixir. And so you're defining, okay, here's our schema, and you can see it's referring to the same tables, basically. And so this is one of the drawbacks of this approach is that you actually just have to recreate all this logic. And so here you can see another example using that same module that we were just looking at in Phoenix is that we've had to rewrite our validations. And if you go back and look compared to our validations in active record, these are actually not exactly the same. And so this is another like serious issue with this approach in my mind is that you have to copy them all over, you have to keep them in sync, and you have to have a lot of mental overhead where you need to know and communicate with the team working on your Rails application if they're going to change, or else it'll just stop working. And so then you can get into situations where you have bad data and it leads to these bugs that are going to be hard to diagnose. And so I think there are a few ways that you could get around this. If you want to do something like this, you could imagine using like database triggers, moving some of these validations or callbacks into MySQL directly. But it's not something that Active Record or Rails really encourages you to do. As a developer, that's not a pattern that most people are familiar with. And it doesn't have a lot of tooling around it that would encourage you to do that. So really, just reviewing those cons, you've got this business logic that's not shared. It's going to lead to bugs. You've got a high degree of coupling. So if the schema changes, if you use Rails migrations, for example, to manage your schema, and then you change the schema and you don't update it in your Phoenix application, then it's going to stop working. And it's just not obvious. Like I said, there's been no changes to the Rails application in this scenario. So if you've got two different teams and one of them is doing this, and the first team might never know because there's no changes to their code base, and then you start seeing really unexpected bugs, you don't know how to diagnose it. So I would not recommend this approach, personally. So now I want to talk about a second approach that we've done. So if the database was our hacky synchronous way of communicating, this is our hacky asynchronous way of communicating. So what we've done here is in our Rails application, we use Sidekick to manage background jobs. We run a bunch of background processes that will pick up jobs off of that sidekick queue and execute them. And so the idea here is that we're just going to go ahead and insert new jobs straight into that same queue that we're already using, but instead of inserting them from the Rails application, we insert them from the Phoenix application. There's actually some pros here because it allows you to reuse the business logic. So if your business logic is written entirely in Rails and all you're doing is in-queuing jobs, then you're going to have access to all that business logic. It's still relatively quick to build, especially if you're not writing new workers. But even if you are writing new workers, it can be built in a relatively contained way. Uses existing infrastructure, so we didn't have to set up any new databases. We didn't have to set up something like Kafka. We already had we already had Sidekick or Active Job or whatever different kind of background worker you use. And it handles failure, right? So Sidekick already takes care of failure cases for us. We're not really worried about what's going to happen if a job, certainly your job can back up, but we know that Sidekick's going to continue trying to execute those jobs. So here you can see maybe an example of how exactly that works. So on the left is basically what we already have. We have a customer web server. It's in queuing jobs, maybe for example, sending emails to the customer after sign up. We queue that, we store it in Redis, and then we've got this background server that's churning through and picking up jobs off of that queue. So all we've added here is, from Elixir, the ability to enqueue these jobs into the same queues that already exist. Now, one of the drawbacks for us has been communication. So this is not obvious to you as a Rails developer that this is going on. It's like the database situation, pretty much just as bad. So this is an actual comment from one of the workers in our code base, where a Rails developer had written it for one purpose. One of the developers in our Elixir project came along and thought it did something else. And then we found out that it didn't. So now, what we had for a long time is that this job actually did two totally different things based on whether or not it was enqueued by our Phoenix application or our Rails application. So here you can see an example of what it looks like to go ahead and enqueue that from our Phoenix application. So we're actually using this hex package called Sidewalk, which is specifically designed to be compatible with the APIs of Sidekick. And it allows you to do is enqueue a job. So you can see it takes class as an argument that's a string, and that's the name of a job. And that's actually the name of our worker in Rails. And then you're passing the arguments along, and then it gets enqueued. So yeah, you can see the cons here. So there's a high degree of coupling because the worker code actually lives in a different code base than where it's getting queued. Again, it's not obvious, and it can also be hard to test. It's hard to build a sort of integration test around this because it would involve spinning up like two different services. You can test the worker, obviously. So those are our hacky approaches. Now, we also have our stable approaches. So I want to talk about using just a basic HTTP API. I didn't say RESTful because we actually have REST and GraphQL APIs. But I think it's got a lot of pros. It's a pattern that's going to be really familiar to most developers, understand that it's going on. It's relatively easy to test. You can just write your basic, same kind of test that you'd write for any other kind of API endpoint. It's easy to document because there's all these different schemas for documenting how APIs work. You can sort of pick your one that works best for you, and it's relatively flexible. So you could actually imagine, for Tote, we use this both for our Rails application to communicate to our Phoenix application by posting to the Phoenix app, and the other way around, the Phoenix app actually posts back to our Rails app as well. So it's a pretty silly diagram, but you understand it's basically they post back and forth using HTTP. So here's an example where we're calling an API in our Rails monolith from Phoenix. So you can see that we're using this module called external service, which is actually a hex package that wraps your requests with automatic retries. So it's got a circuit breaker built in, so if the other service isn't responding, it'll stop sending requests for some sort of timeout period. If the request timeout, it'll retry with either linear or escalating periods between. So every 5 seconds, then try a minute, then try 10 minutes, or however you want to configure that. And so that's something that we just imported in, and then we're just using this HTTP poison module to send the request and then respond to the request. So it's pretty straightforward. That being said, it definitely has some cons. It's slower to develop because you need to coordinate better among multiple teams. You need to really define your requirements better ahead of time. So it's definitely harder to just go out and build something. You're constrained by other teams if the same team is not developing both your Rails and your Phoenix application. And you have to manage deployments to make sure that you can actually go and get your API out into production before you need it. And if you want to update it without versioning, something like that, then you either have to have some process. Okay, we're going to deploy both of the apps at the same time, or you need to employ versioning or something like that if you want to change it. And last, we have our stable asynchronous approach, which is a message queue. So for Tote, for us, this looks like we use Kafka. I think there's a lot of different choices out there, and people use different ones depending on their situation. So this got a lot of pros because it's actually designed for communicating between applications, unlike your background jobs. So typically you've got failure handling. It's easier to test. I think it's more obvious and it's a clearer boundary. Like you can tell that when you're ingesting a message that it's probably coming from a different application, or in any case there's sort of some expectation there. Yeah. So you can see you've got your producer writing a queue and the consumer is going in and reading off of that queue. So here's an example from our code base where when we update one of our products, we want to encode that as sort of a standard message format and then publish it to Kafka. And then on the right, we've got our Phoenix application, which is actually going to accept that message and then do something with it, which is ingest it and actually save it into the repo, which is all wrapped in Ecto. So it's kind of cool on the right-hand side how this works in Phoenix is that we actually have a separate OTP application within our trees, just responsible for consuming the messages off of Kafka. So they actually get spun up at the same time. They have access to the shared models, and then you can write directly to our repo. That being said, this has a lot of cons, and this has actually caused a lot of issues for us compared to our hacky approach. So we had to set up new infrastructure. We had to set up Kafka cluster. It's been a huge problem for us to manage that Kafka cluster as well, because we initially set it up on Heroku, and then we had issues where Heroku didn't have the availability that we wanted, and we had to change out the certificates, like lots of configuration, and it's been a lot of overhead. And now we actually have somebody who's on call who has to respond to all the issues when we're having issues with Kafka. and you have to manage and see when it stops working. Just because it is an asynchronous request, it's not necessarily suitable for real time. So it's not going to be the solution for every case. And anecdotally, I've heard that Rails as a Kafka consumer, like accepting the messages, doesn't have great performance when it comes to memory. So when I think about the different approaches that we've used and which ones I would recommend and which ones I would not recommend, I would definitely not write straight to your database. That being said, we're still doing it, and it hasn't taken down our company, and it does work at some level, but don't do it. When I think about the background jobs approach, actually all the problems that we had with the background job approach were not about the technical aspects of implementing it, but really about the communication between teams. So technically it's worked very well. It was nice that we didn't have to set up any additional infrastructure. It was nice that we could take advantage of stuff that we're already using. But the major problems have been around teams not communicating well. So someone would go in and pick the wrong worker, and then because our Phoenix application is now using that worker, then we have to go back in our Rails application and make the worker do what they thought it did, in addition to what it was actually supposed to do, and continue to support that indefinitely. So I actually might actually suggest doing this, especially if you don't want to go through all the hassle of setting up Kafka or some other kind of message queue. But I would say that you should go ahead and communicate really clearly from the outset what your goal is, what you're doing. Maybe think about putting your workers in some sort of module that indicates where they're going to be queued from, and just really think about and over-communicate that from the outset. Because again, one of the reasons that we started doing all of this in the first place is that our team was growing, and we wanted to be able to work more independently, but this approach doesn't require you to communicate. It doesn't just magically, it doesn't have patterns that enforce communication between developers. With the HTTP API, this is probably the aspect of our distributed systems that have given us the least trouble. So you should probably do that. And then with the message queue, it's worked for us, but it hasn't always been smooth sailing. So there's a lot of setup. It's got a lot of problems. In terms of like the Kafka clusters going down or getting backed up or behaving in unexpected ways. And honestly, as a development team, we don't necessarily have a ton of experience with managing that on such a small team. And so it's supposed to be more stable, but I don't know that it has been. So my lessons that I would share is define your boundaries first, communicate between your teams about what you want to do before you start writing code, before you start inserting records straight in a database, or using random workers that don't do what you think you do. Definitely have a strategy before you start writing code. Think about how you're going to handle failure. And yeah, hacky solutions could be the right approach for you. They were the right approach for us. So I do want to give a quick plug here. Tote is hiring in San Francisco for US-based developers, also for remote developers in the US. And Tote also launched in China about 6 months ago now. And so if anyone is interested in working in Shenzhen or remotely in mainland China, we also may be hiring for some roles, so feel free and come and ask me about that. All right, so I did want to leave some time for questions if anyone's got questions.
Got any questions? Anybody got any questions?
What's the scale in requests per second for the inter-service communications? And which one is the majority of among the 4 approaches that you take?
Yeah, I'm not sure the exact numbers. I can look it up. But in terms of the most volume, it's actually the background workers. Everything else is only used maybe in one specific spot in our application, and that's the technique that we use most broadly.
You mentioned that you had a Rails monolith prior to splitting the application up. Do you still have one Rails application, or are you splitting that itself into microservices?
Yeah, that's a great question. On our Rails side, we still have one monolith, and there are additional parts of the application that we decided to split out besides just our fulfillment-oriented software. So for example, one of the other services that we want to split out is something that internally we call Catalog, which is a tool for our buyers and merchandisers to manage the different products that they buy and tagging those and giving attributes to those. So for example, like when they buy a shirt and taking all the measurements, what color is it, all the different aspects that go into that. And so we're splitting that out into another service, but that's something that we chose to use Elixir for as well. And not necessarily because Elixir necessarily lends itself well to the domain of a CRUD application where you pick colors and enter the name of your product, but because we just decided to go Elixir first on all services going forward. So we probably won't split out more parts of our Rails application into other Rails apps or other Ruby-based applications.
Okay, we are open for one last question. Any more question? Okay, gentleman from the back.
When you try to, so you mentioned you have asynchronous and synchronous ways of communicating. How do you decide, like, if one task is supposed to work for synchronous communication or the other, or is it always clear that this kind of task belongs to synchronous and this other kind of task belongs to asynchronous?
Yeah. I think in general our philosophy is to use asynchronous communication in every situation where we possibly can, because it also helps with managing failure, right? We don't have to worry about the availability of one of the other services as long as you've put an asynchronous queue. If that service goes down, when it comes back up, it'll just get handled. So for example, I think one of the only places that we're using synchronous communication is where we need to like buy postage labels, and we absolutely can't move to the next step unless we buy the label. So that's a situation where we use synchronous, but otherwise trying to use asynchronous.
Thanks.
Okay, thank you very much for your sharing. Okay, our next session will start